Okay, the name of this class is basically, what did I put? Niagara R2 control objects. These are the very basic, out-of-the-box control objects you get with R2. Sometimes, depending, no matter what level you're at, no matter what your job is, you find yourself in situations where you need to put some logic together in a UNC. Not necessarily making full-time software writers out of everybody, but it's nice to know that when you're in a pinch, you're out in the field and you need to put some logic together. You have the resources. You don't always have to call on somebody to do that. So what I have here is basically a station with an empty container. Those of you who are used to working with this is a Niagara container. This is where we put the building blocks together. Typically, to access our control objects, if you see where my mouse is up right now, we have a monitor mode. We can switch our screen from a monitor mode to edit mode, back and forth. So we do need to be in what we call the edit mode in order to click and be able to move objects around on our in our container, as we call it. If you see to the left here, I have a container. I called it control objects. If I right click anywhere in my work area here, I'm going to get a drop down menu. What I want to do is move down to new, and you get a secondary drop down menu. I need to go over to control, and there's the whole list of the out-of-box control objects that I was talking about. Many of us are very, very familiar with these. We'll get into the basics of them, which a lot of you probably know, and also some advanced things that some of you may not have known about these objects. And I'm going to start from the top. The only thing I'm going to do is skip the analog command because I'm going to use that just a little bit later. I was going to start with the first object, analog input. So if I select that, we do nothing more but add an analog input. This is probably our most commonly used object. It really serves no special purpose other than what we do with it is typically grab values from controller type objects. So if we have a controller, whether it's a backnet controller, a line controller, or a network 8000 controller, if we want to put a label on it and a tag rather than linking directly from the controller itself, because when you do that you really don't know what it is. So a lot of times we'll take these AI objects and we will rename it, and I'll put in just a RMT, and now we know for sure that that is the room temp. That will link right to, a backnet object or a LAN controller or something that it's not going to be labeled quite like that. So a lot of times in the programming world, we try to make things a little easier for the people who have to follow the software, and we make these little IA tags for everybody so you don't have to open up a workplace tech program to figure out what the heck this point is. So we clearly know that it's a room temp. The other thing we use these for are for global purposes. Say we have a job with an enterprise server and 3 UNCs. We have one controller out there that has an outside air temperature sensor. Of course, that means only one UNC provides this outside air temperature sensor. We need to share this outside air temperature sensor with all the controllers on the job. So a lot of times we'll take an object like this, and I'll have it. You'll see in a lot of my jobs there's always a container I create called global, and within there I'll make an outside air temp tag, and what I'll do is I'll use that single point to link the outside air temp from the UNC of the source to the UNC in the global container that does not have it, and all of a sudden this becomes that UNC's outside air temperature. So from within here, then I will link the output of this object to all the other controllers that require outside air temp. I hope that makes sense. A couple of the things in the properties of these objects, if we right click the object and we go into the properties, and this is very basic, but some of the things we often do, especially for graphic purposes, is we want to set the units. So if we go to the config tab, you can set the units of this, because this is what will display on your graphics when you link it up to a monitor tag. This one in particular, we're going to use temperature, and we're going to use degrees Fahrenheit. And we will save that. Okay, we also have what's called a COV increment here on these AI objects. And little rule of thumb, where it becomes handy to use this is anytime you're using this for a global object like an outside air temperature sensor, it is best practice to set this up with a little bit of a COV. Like I may set up a COV of a 0.5 or maybe a value of 1. And what happens is if I share this to like 50 controllers that are looking for outside air temperature, what that will do is that'll save a whole lot on the bandwidth of your communications, whether it be BACnet, whether it be Network 8000, or whether it be LAN. By putting in a COV in there, you're not writing constantly to that input of the controller as it goes down to the controller. So it'll only write when you exceed this COV value. So if your outside air temp is sitting around 30.1 degrees, when it goes to 30.2, it's not going to write down to the controllers. It's going to write down to the controllers after it exceeded a full value of 1 or whatever we put in the COV. Any questions on that? I know COV, we'll be talking about COV a lot more in other classes. It is a little bit more of an advanced feature, but when building jobs, it certainly does help a lot to use the COV, especially when sharing a lot of points. Everything good on that? There's nothing really much more under the visual tab, and I'll go over this now because this visual tab, this is pretty common for most of the objects we're going to go through. If you want to set a precision, what that precision is how many decimal places do you want to display when you link this up. What I'm going to do is I'm going to back out for a second, and I'm just going to go click New GX Object, and I'm going to throw what's called a GX text into the mix here. And I'm going to link, because this is the GX text is what we use to display values on our graphic screens. I'm going to link this up. And we'll get into linking and all that kind of stuff in other classes, you know, because these are only hour-long classes. We got to really stick to the guns. But we're going to have a lot of very basic classes like this, maybe some just on linking and whatnot. But as you can see in the monitor mode, we've got a value of 0.00. There's 2 decimal places there. I'm going to make this a little bigger. And you can see there's our units, our degrees Fahrenheit comes out. If I go back into the properties of my AI object, and again, this is for any object that displays analog type values, I'll take my precision down to 1. And now you can see we just have 0.0 instead of 0.00. The big problem with precision is, and this has gone all the way back to early years of Niagara, is when you link these externally from UNC to an enterprise server, okay? Anytime the link goes outside of the UNC, you lose the precision and it defaults back to 2 when it lands in the destination folder. So that's kind of a pain. Later on, we'll get into other ways on how we fix that. If you want to do a job that you happen to be a little fussy about how all the decimal places play out, there are ways around that. And we'll get into that in some other classes. So just make a note. You don't have to go through, and if you're in a UNC and you're going through and setting all your precisions and getting them ready to link to a server, you can forget playing with precision because it's not going to help. Most objects have they have alarm properties. We use these quite frequently. Starting with the top, we have a time delay, and oftentimes we usually configure our alarms up in the enterprise server. Reason for that is we just decided we needed to go with a standard. We picked the server, and we used to have problems in the early days where UNCs, if the alarms were in the UNCs, sometimes your acknowledgement would get stuck, and you couldn't acknowledge them because you acknowledge them from the server, and if the server couldn't get that message down to UNC, you'd have what's called a stuck alarm. I haven't seen that happen in a lot of years, but ever since then, we just kind of been putting them in the server, and we stick with it. Oftentimes I do, because sometimes you get glitches, so I will often put time delays, sometimes a minute, just to make sure that the alarm is truly valid. Notification class, you just typically stick with the default to 0. Maybe I'll have a class in the future where we'll get into some advanced alarming. Event enable. Typically I just pick to off normal. I don't like cluttered jobs with a lot of nuisance alarms. Sometimes a customer, basically, if the value goes into alarm, that's what you're going to see. It goes to an off normal value, and that's when the alarm shows up. If you actually wanted to see a return from alarm, which you can do that, you would check the to normal. So every time the object goes back into a normal state, it would also pop up a new notification telling you it went back. But I usually don't use that because alarm screens get pretty busy to begin with. Notify type, I always set them up as alarm. Inhibit time, I usually don't play with. That's a little more advanced feature, but you can use that as a type of delay. Alarm text. This is very valuable to fill in your alarm text, because if you do not fill that in and you go to the alarm screen looking at alarms, most of the times you will have no idea what this alarm is about. So I'll put, I'll just put building low, because this is an outside air sensor, low. Not that we'd ever alarm an outside air sensor, but just for training purposes. Building low OAT, outside air temp. That way, with an alarm text in there, in the alarm screen, you clearly see what the actual alarm is. Very important to put that in there. Then down near the bottom here, we have our high limit, we have a low limit, and we have what's called a deadband. We'll just play with a low limit here for the time being. I'm going to set, every time the outside air temp drops below 32, below freezing, I want it to be alarmed. I don't want it to clear out of alarm until the outside air temperature gets back above 35. What that means is I need to set my deadband of 3 degrees. The same would go if I put a high limit on there. Say I want a high limit of 90. And if I had a deadband of 3, that means when the temp came back down below 87, it would clear back out of alarm. But we're just going to go with a low limit, and I need to check this box for the time being. That is typically how we set up a very basic alarm. Putting the AI object aside for now, we're going to leave him out on the screen. I'm going to pull the next object in, and that is going to be an analog output. Another object we're very familiar with, very popular. An analog output is more of a command type object. Graphically, what this object does is gives you right-click capability on a graphic screen where you can set a value. This is the type of object we use to simply have adjustable space set points, mixed air set points, discharge air set points, time intervals, any type of value you can possibly think of that you may need to have the customer right click and adjust will come through an AO type object. I'm going to rename this, and I'm just going to call it manual OAT because we're going to play with outside air temp. You'll notice on this object, though, the analog input has you see a little SIN and a little S out, okay? And what that stands for is it's a status input and a status output. And the orange color that's up there, I know it's hard to see the colors, it's orange, represents a float type status, okay? Float means it's just a number, an analog type value that can, just can move, floats, do whatever number you want it to read, it'll read it and it'll move along, and whatever changes. So we call that a float type, a status output. You'll see this consistent with the other types of objects, but you'll have status outputs and you'll have priority outputs, okay? On the AO, you'll see a PIN and a P out. That's going to be, we're going to get into that in a little more depth in this class here, and that's discussing the priority outputs. When it comes to linking objects together, you can only link together the same types of connections. So what I'm trying to say is, if I wanted to link this analog output object to this analog input object, I can only link the status out to the status in. I cannot link a priority out to a status in, even though they're both orange. And when I link this up, as you can see, I highlight my status input, and the only thing that lights up are the items that I can link. The green items are what I can link. So we've got the status output, and I can link that to the status input. Status feedback out is something that would be more advanced. We've never used that before. But as you can see down, I have a prioritized output, and it's red. It's not going to allow me to make that link. And what I'm going to do is just complete this link for now, and you'll see what purpose it serves in a minute or two here. When we go into the properties of our analog output, we go to the priorities tab. What you're going to see is that priority array inside here, and you're going to see 16 levels of priority, and this will hopefully all come together in a minute or two. But it works. Anybody who's got some old Network 8000 programming experience, it works identically to the DOs and AO objects you'll find in LCMs and GCMs. It's got different input priority ranges. Relinquish default. Very, very important value you typically want to put in when you are programming, because upon reboot, your object will go back to the, if anything happens, you want a valid relinquish default. If you created a job and you did not pay attention to that at all, and you left a 0 in there, there may be a chance down the road something happens, you restart the system, and all your space set points are now 0 degrees. That wouldn't be too cool. I'm going to put a default in here of 40 for now. And when I hit 40 and I hit apply, you'll see the relinquish default in the priority array, which is at the bottom, is set to 40. Just keep a little mental note of that, because you'll see a little bit more how the priority array works in a minute. Under the config tab, there's nothing different here. We've got our units, and I'm going to set temperature degrees Fahrenheit. I'm not going to use COV. We have alarm if we want to do alarm, and under the visual, The visual gets to be the important part on the command type objects. Um, the area I'm referring to is command tags. What these command tags are is basically when the customer right clicks on the graphic screen, what do you want him to see? Usually in a straight set point situation, like if it's just a straight space set point, we'll get rid of the manual auto, emergency set, and emergency auto, and I'll just hit enter, and by default we just use the word set. I'm sure a lot of you have seen. Let me make another GX text here and I can demonstrate that. So if we had this GX text object here on a graphic, I can right click that and you'll see set comes up and I'll be able to put in a value. Now this is the interesting thing is notice on the left side of the analog output while I'm in monitor mode here, you'll see 41 degrees at 8. Okay. We're going to go back into the properties of the object, and if I go to the priorities tab again, you're going to see the priority array. It says manual operator 8, 41. You'll see the relinquished default at the bottom. Basically, just like an input priority range, the higher, actually the lower the number or the higher on the list there is going to be priority. If I made this manual operator go away, it would fall back, it would continue down looking for the first valid value, which is going to be 40, is going to be our default. And we're still going to play with that a little bit more yet. Under the visual tab back again, what we typically use is we never use emergency set or emergency auto. I've never had a reason for it, never used it. But what we do use often is manual set and manual auto. And if I were to put some text back into auto and made that a right clickable feature on the graphic, we're going to go back to the graphic and I'll show you exactly what that does. If I right click, and you'll see now I have set and auto as options. If I select auto, you'll see now the object says 40 at default. So typically what I did was I cleared and we'll call it more almost like an override, I cleared the manual operator 8 and I put that into auto. And that's all you're doing when you click auto is putting manual operator 8 into auto. Now I'm going to have a class strictly on remote local set points, I call it. When we have jobs that have S3, S-Link sensors down there and we want to give the customer capability to right click on an object and use either the local set point or the remote set point, and we can do this in any generation of controller, whether it be LAN, BACnet, or Network 8000. One thing to keep in mind when it comes to programming, one thing we're always trying to do is build logic with using the least amount of resources, the least amount of external links, the least amount of objects to do something together. So this is where this comes in real handy in making user selectable local remote set point control. And one of the things you can do in your AO object is you can make your relinquish default NAN. And who knows what NAN stands for? You see this a lot in Niagara, and a lot of people really don't know what NAN stands for. Anybody? Alright, Rob gets it. Not a number. What happens, what's nice is, just keep that in mind for the set point control, because what happens is, and that's a whole nother class, but that NAN we can send down to a controller and use it in a priority type input down at controller level, which we'll go into detail, but that comes in real handy for doing remote local set point control. So really, technically, the inside of the analog output object, the two command tags under the visual tab that we use is manual set. So when you really think about it, when you select manual set, you're doing nothing more than writing at priority input number 8. When you select the auto is doing nothing more than putting priority input 8 into auto, which passes along the priority to use other priorities. So kind of funny, but not everybody has always looked at analog output objects in that way. But when you understand it that way, it's pretty handy. Some objects allow you to actually adjust the priority for writing. This one does not, so it's always a manual 8. What I'm going to do is I'm going to go back, and I'm going to, as you can see, we're sending our analog input value of 40, and our AI object is now out of alarm. Any questions on the AO object? We're going to move back up now, leaving what we have out on the screen here. I'm going to go back to the top of the list and grab this object called analog command. He's a cool little object. These are like some of my favorites. I wish they had a little more flexibility to them. Analog object gets used, analog command gets used typically in two different applications. For those of us with LAN experience, analog command is the only object that can read and write to an NCI type snippet. So analog, we got familiar with them awfully early because when we started Niagara, we were heavily into LAN controllers. And NCIs were pretty popular, and the CP analog object was the only one that could link to an NCI. The other thing we can do with the NCI value is actually use it to adjust certain parameters inside of other Niagara objects. For example, we have an alarm configured for our outside air temp, okay? If you remember, we had set the alarm for that to alarm anytime we're below 30 degrees. Well, let's say I want to make that alarm set point adjustable for the customer to use on a graphic screen. If you can see, if I make another GX text object and I try to link that value straight to the GX text, you're going to see that I can link it, the low limit. We can read it as 32 degrees, but if I go into monitor mode, as you can see, if I right click on that, I have no options. I cannot change it. I can read it and display it, but I cannot change it. I want to make this something that the customer can change. So that's where these analog command objects come in handy. And as we go into his properties, they do work a little differently. We go right to the config tab, and the first thing you have to do is you have max value and min value. You can actually have limits. And if we get more into set point control where you need limits in Niagara level, you can use these limits as limits, but they are a little bit special too. They don't write normally like an AO object does. You have to, there's a little bit of magic you got to use to make them work if you want to use them. But we're going to put in just max value of 100 for this object, the min value of 0. That's going to be our range. You'll notice under this config tab there's no engineering, there's no units. I can't label. That's the other problem with this object, is I can't make it degrees Fahrenheit or inches of water or anything like that, which is fine because there's ways I can do that graphically anyway if I really need engineering units, so it's no big deal. We'll get into those objects in another class. Under the visual tab, we do definitely have to write our command text. That command text is our right click feature. And I can put in something like set OAT low limit.